All right, 2, 1. So welcome back. So this is now going to be the beginning of basically the grade 10 video series. So in this video, I'm going to kind of go over linear equations again, and in particular talk about the input and output viewpoint from linear equations, table of values, talk about restrictions, so domain and the range, something that maybe you have heard of or not, and then graphing. Now, linear equations you have covered in grade 9 already, so I can put, and I will put, a link to the entire playlist, right? So things like slope and intercepts, okay, so graphing and everything else, already covered. Now, why is it covered again in grade 10? Because of the fact that you want to be able to review, and also these concepts are used in grade 10 to try to find other things and get you thinking about the concepts of graphing, and then concepts in terms of restrictions and things, points, lines, and things of that nature. So let's get into this video, and I'll start from the viewpoint of input and output. And I do encourage you to watch the whole thing, especially the concepts on restrictions based on domain and range. Again, all right? So that is a topic that you definitely will see when you get into, for example, grade 11, you start talking about functions. So it's a good thing to start getting it in your head and prime yourself for it. So input and output, okay? So I'm going to go back to this view. So here, let me just kind of shift it up a little bit. Now, I like to introduce these linear equations, which a lot of people kind of remember them by simply, okay, known as kind of y is equal to mx, where m is the slope, plus the b, and the b is the y-intercept, right? So if you've taken grade 9, you should have covered this, and if not, you should go back to that link that I pointed out. Now, there's a lot of many other things that are related to these. So now here you have your y and your x. All right, so here is your y, and then here is your x. The slope m is pretty much a constant, and it is given to us. Now, it doesn't have to be in this form, a line, that is. It can be in many other forms. It can be in a standard form, and in that standard form, you know, you may remember it might look something like this: ax plus by plus c is equal to 0. And then even some teachers might simply write it as ax plus by, where the c is on the other side. All right, so one of those two. Now, with this, okay, so the x is known as your independent variable, and it is the input to a particular system, and then you're creating a relationship between your x, your input, and then your y, which is your output. So that's how I like to transform these in here. So I like to say that x is the input, and it is known as the independent variable. Independent variable. So we do not have control over this. So for example, time, right? We may not have control over time, but there are many other independent variables that you can run into. And again, so independent, that is a topic in grade 9. I'll try to put a link up above, all right, if you need a little bit more, but hopefully you will grasp the concept from this video as well. Now, your output. So your output is basically dependent on that x input. So this is x, which is your output, say to some system, okay, that you may have. So that's what you have there. And this is known as the dependent variable. So it depends on the input x. All right, so it is dependent. So notice here, if you substitute for x, you can always get your value for y. So y depends on your input x, whatever that might be. Now, because this is just linear equations, our actual line always is going to look something like y is equal to mx plus b. Maybe not always, because if you have a vertical line, you may remember from grade 9, all right, that vertical line doesn't really have y is equal to mx plus b because there's no slope per se, all right? And I'll give you an example for that. So if I take an example here, so I'm going to paste here an example that we have. This is 2x plus y minus 1 is equal to 0. So it looks like it's in standard form, right? In this ax plus by plus c form. And now, what is the input and the output? So one of the things I wanted to kind of discuss and go over is this table of values. So creating table of values. So going back in time, forget the whole graphing thing, you know, the slopes and intercepts. Start back from the foundation. So if you have this and someone actually provides you these values for the input, so whatever these values might be, you can create a table of values for your input and your output. So I'm going to create one right here, and this is your input x, and then this is your output y. Now, when you're doing this very often, so 2x plus y minus 1 is equal to 0 isn't very convenient for us to use. So what we like to do is we like to put this back into the y is equal to mx plus b form. So meaning isolate for y so that when you substitute for x, it's very easy to get your y. So now substituting these, so if I bring the 2x over on the other side and the minus 1 over on the other side, you will get that y is equal to, and this will be negative 2x plus 1, right, when you switch them over. And now you can substitute any values you like for x. So at the top of the table of values, we typically start with the lower values and then they get bigger as we go along. So for instance, I can, for instance, say negative 2 would be my first input, right? And then I want to check what my output would be. And then I can do the same thing for negative 1, which would be your input, and then maybe 0, and then maybe 1, okay, and then maybe 2, okay, all the way down here. So that's what you would have. So now for these, let me insert a page here just so that I have some space in between. Now I can go ahead and evaluate what the y value is, what my output is for these inputs. Now these inputs, I've chosen them arbitrarily. Now, and most people will choose them as integers, right? But you could have chosen negative 2.1. You could have chosen 0.5. You could have chosen 1 over 5. Whatever it is that you like. But you typically keep them conveniently as integers, and then you would go ahead and take that table of values and maybe possibly graph it, right? So that you can see. Now, everyone knows that for lines, all you really need is just 2 points. So your table of values is kind of redundant if you start doing more than 2 points. But sometimes you do have more than 2 points in a table of values, just dependent on the question that you have. So let me go through these, okay, and I'm going to fill it up and, you know, hit kind of the fast forward button so that you can see what those outputs would be. All right, so welcome back. So notice what I did was I just inputted my x's into my equation, my relationship between y and x, and then I got my outputs. So my corresponding outputs. Now, these are actually points. So if you ever graph them, you know, you would have an ordered pair. An ordered pair meaning you have an x and then a relationship with y. So very often, the way that we would write these out, you know, you'd write them out as an ordered pair. So negative 2, this is your x value, and then this is your y value. And then here you have a negative 1, and this would be tied to 3. And then this one would have been 0, and it would have been tied to 1. This would have been 1, and it is tied to negative 1. And then finally 2 is tied to 3, okay? And this would have been negative. So let me fix that up there, okay? So that's what you have that. Those are just ordered pairs that you can now plot, okay, if you wanted to. So this is basically the table of values that we have, and then we can use this table of values to graph. All right, so now we can actually try to graph these, right? And then so sometimes what may happen is that you're going to be taking these and you can graph it. Now I've changed this to graph paper. You've noticed that it's kind of updated, right? So we can do this. We can put our, so let me draw a little better. So I have that. So this is my X, this is my Y. And you can use a graph paper to try to graph these points. And then from the points, you can draw an actual line. So I'm sure that you've done that in grade 9 quite often. Now, what I encourage students to do is not just to do it by hand, but also to try to utilize tools. So here, for example, I'm going to take these table of values, so -2, 5, -1, 3, and so on, and I'm going to plot them. And I would encourage all students to try to utilize some kind of an application, like, for example, Desmos. So you can use that. Sometimes you have graphing calculators. Now, the applications that we have now are way better than some of those graphing calculators. And you can do table of values and graphs on them as well. So for example, this one, I'm going to hit the plus button there and I'm going to put a table, right? And then so here, and I'm going to input into this table, okay, the actual values. So that's what I have there. So -2 and 5, -1 and 3. Right, and then I had 0 and 1, and then I had -1, and this was 3, I believe, and then it was, so let me go back here, just make sure that I'm plotting the correct ones. So -2, 5, -1, 3, all right, 0, 1, okay, so let me go back and fix that up. So -2, 5, -1, 3, 0, 1, okay, so this was 1, all right, and that was, okay, -1, and then this was 2, and then this was -3. So now if I zoom out here, you notice that those points are being plotted right on. And that's the actual line itself. So in this tool, I can actually also plot the line. So this was y is equal to -2 plus 1, sorry, -2x plus 1, and notice that it goes directly through those points. And you have now graphed the line itself. So those graphing exercises that you do, okay, try them. So take a few, you can use Desmos, try it by hand as well, so that you get familiar, and then you can do the table of values, the points themselves as well. All right, so that's something that happens. Okay, and this is definitely a part of grade 9, but this is worth reviewing in grade 10 right in the beginning. Okay, so that was kind of the input-output table of values, and then we can graph things out, you know, and you can try them on your own. So I have created a few of these, okay, so notice here I have basically 5 different lines. And one of the things, okay, so this one, the first one is the one that we just plotted. So that was the one that was plotted. Now here is a second one, okay, so here's a line right here, and you may look like, and you said, this is no X and this is not Y, right? This is V, and then there's a T. Because the reality, these X's and Y's, these inputs and outputs, they represent something. So for instance, V, okay, might mean volume here, and then T, okay, may mean time, right? So your independent variable now is T, which is time, that's your X, and then your output is V, okay, or capital V. And now here is something which is funny. So you have here a set, all right, in these braces that you have. Now, we have seen, okay, these before in terms of braces, right? You had the natural number set, integers, real numbers. If you have forgotten those things, definitely keep them in mind. I'll put a playlist up above for you for that, all right, if you've forgotten those particular sets. Now, here, okay, there is a restriction. So we call this a restriction on T, right? So this is the restriction on T. So if you were having and you were drawing these inputs and outputs, so if I'm going to copy this down here, all right, so I'm going to take this, okay, duplicate it, and then bring it down for us so that we have it there. So what this is saying is that now your input is time T, all right, this is your input. And now we are restricting this input. We're saying that this input is basically between 0 and 4. So whatever this might be, maybe time is in seconds or minutes. Now you will realize that oftentimes time will start at a particular point, right? It may not necessarily go backwards, because whatever experiment that you're doing it is you started it at a certain time. So maybe you call that time 0. And what that does is, okay, so this basically creates something called a domain. All right, so you have a domain within. So in this domain, okay, so it is a set. And in that set, t is being restricted. It is being restricted to only live between 0 and 4. It cannot go above that. So your inputs into whatever your system you have are being restricted. Your domain is only allowed to be between 0 and 4. So there is no -1, there is no -2, right? And then there is no 5, no 6, no 7, nothing like that. It's so you have restricted your input, which will also restrict your output. So there's going to be a restriction there, and we'll see that because we're going to take this and we're going to graph it. So now how can you graph it? Well, you can definitely graph it using a table of values, right? You can substitute, t equals 0, t equals 1, 2, or whatever value you want. Or you can take literally this and graph it as it is. So notice the 3 is really your slope. Your 4 is your y-intercept. So you can graph this, okay, right away using a table of values or the actual graphing tool that we had here. So I'm going to get rid of these, okay, right there. And I'm going to put in, so this was now v is equal to 3t and then plus, now I forget, 3t plus 4. So this would have been 4. But now we have this restriction on the domain, right? On the input. We're restricting it to live only between 0 and 4. So this graph, as we have it right here, it's not going to go on forever as it's going. So I'm going to go back here, and here it says that I am restricting this, okay, to live between 0 and 4, as so. So notice what happens. All right, so now I have restricted this. So my restriction now basically lives, right, in this world between 0 and 4. So I'm going to kind of extend this out so that it shows me. And then here I'm going to take a snapshot of this and I'm going to input it back into our actual, okay, notes. So let me do that. Save that photo. Let me go back. Okay, and I'm going to insert this photo back in here because I want to talk about it so that you can see it and then base it on these restrictions. What do they actually mean? So if you're looking at this, so what you had is, so right here we have restricted our input. So this was between here and here, all right? So that is basically between 0, so this is 0, and then this is 4. It can't go beyond that point, okay? And it cannot go beyond that point. This is called your domain now. So that is your restriction based on your domain, meaning your input only lives between 0 and 4. That's the domain. Your output, whatever your output is, notice it also got restricted here. So here, just because once you restrict your input, your output gets also restricted. Now it can only live between these values. That is called your range. So this is now called your range. So your range is basically what your output is allowed to live in. Notice it can't go beyond, okay, so I believe that was 16. Let's go back here to the actual and see what that point is. Yeah, it was 16, right? So it can't go beyond 16, and then right here, well, it's not going to go on below 4. Okay, so that's what happened in this particular example that we had. So our range now all of a sudden also got restricted. So now our range is between 4, so that's what it lives between, and then your maximum is 16. So those restrictions that we have, we can put them because it doesn't always make sense to have values, for example, sometimes that are negative, all right, or sometimes that are something else. That depends on the actual question you may have. Okay, let's say you were counting the age of someone, how old someone is. You can't say they're -1 because it doesn't make any sense. So if you're talking about your age and then your age was your actual X value, you would have to restrict it. It can't go negative, right? So you basically have to put a restriction on the domain, and then the domain most likely is going to go to some maximum, right? It's not like somebody can live 200 years, at least not yet. So your domain gets restricted that you have. And that happens very often. Imagine that you were, for example, filling a bucket of water. Well, that bucket of water, you can't have negative water. So again, you would have to put a restriction. So when you're going to be studying math, sometimes you will have these restrictions on the domain, which is your input, or on the range, which is your output. So your domain gets restricted, and then your outputs gets also restricted on the range, because it can't live in all of these. And here is a perfect example of this. Right? So I want to kind of go back. I'm going to skip number 3 and I'm going to show you number 4. So if I take this example and let's say this was a line. So I'm going to copy this down and I'm going to put it in here. Okay, so now let's talk about this line, right? Because this is not a regular standard form line in terms of y is equal to mx plus b, because this does not have a slope. So if you do this and this is a line, someone says this is the equation of a line. So what you have is x is equal to 3 over 2. Now you might say, this seems like it's a point. But that's not true, right? What this is this is a vertical line that goes through 3 over 2, okay, on the x-axis. So here, if I would graph this, okay, if I put this line in here, so let's say x is equal to 3 over 2, okay, so notice, I am restricted. Notice, your domain, right, there is no 1, there is no 0.5, there's no 0, there is no 2, there's no 2.5 for x. Your input is restricted to 3 over 2, which is 1.5. It cannot live anywhere else. That's your domain. Your domain is a single point on the x. It's only one input. But your range, notice, okay, unless someone restricts it, your range is basically all the values of your output. Because for every input of 3.2, all of a sudden, you have a range which is infinite points going up and infinite points going down. So this was a great example of trying to understand the domain and range. So here, your domain that you have is basically just a single point where x is equal to 3 over 2. That's your domain. It cannot live in any other input. But your range is not restricted. So your range that you have, your output y, is basically any real number. It can be any real number because it can go up and it can go down, right? So y, we would typically write it as any real number. Now again, that was the link that I was showing, of people remembering the real numbers, integers, whole numbers, things that they think that they can just forget, right? But you can't. Okay, so I encourage you to go back into that link that I pointed out before on the set so that you understand the real numbers. So that's the domain and range on this one, okay, because it's a vertical line. Now take a look at the number 5. Number 5 is 2y is equal to negative 4. So for this right here, okay, if I would isolate it for y, I'm going to just divide by 2 on both sides, and I'm going to get y is equal to negative 2. This is a flat line, right? It's a flat line that I can plot. So here, if I go back and then I input y is equal to negative 2, so notice what happens. Okay, it's a flat line. So now your domain, so the domain that you have, okay, is basically any x that you can carry. Okay, so any x. But your y, your range, is just y is equal to negative 2. Right? So your output is stuck to negative 2 no matter what you do to the input domain. Okay? So this is another great example of how these ranges and these domains come into play. So for this one, if you have y is equal to negative 2, here your domain, So there is no really any restriction. So x is basically any real number that you like. But your range is stuck. Okay, your range y is restricted to basically just -2. It cannot be -1, it cannot be 0, it cannot be 5, it cannot be any number except -2. So you're stuck on the range. So for those who haven't covered ranges and domains before, or restrictions, these are really good, okay, to think about. Now, I'm just priming you. You may not have this necessarily, okay, in your grade 10, but I do want to let you know about these restrictions that you can actually block things off, okay, between a range here. Here's the last example, okay, so that number 3 right here, so this one, okay, so that we have. Now this one, notice, has a restriction, so I'm going to copy it, bring it down, I'm going to paste it. This is another line. Now it's not necessarily in standard form in any way. Notice the y is on the left hand side. Okay, so 15y minus 10x is equal to 12. Can we graph it? Of course we can. Notice we have a restriction on the range, okay, on the y, which is on the output. So we're being restricted between -1 and 4. Okay, so that's what we are being restricted on. So now I can plot this out. So 15y minus 10x equal to 12. So I'm going to plot it. Okay, so let me add that in. So 15y minus 10x is equal to, and then, okay, so it's 12. And then we have our restriction. So this is 12. And then I have a restriction on the y. All right. So my restriction on the y, this negative, so this right here, -1 and 4. So that means my range can only be between -1 and 4. That's clearly going to also restrict my domain, all right, on my inputs that I have. So my domain won't be able to be outside of certain boundaries. So if I do this, so this is -1, whoops, okay, so this is -1 less than y, okay, less than 4. All right, so let me do that. Okay, and now with this, so if I scroll up here, let me get rid of some of these other lines in here so that I only have one. So notice what happened here. All right, so you have a restriction on the y, which automatically restricted our domain x, our input, because the line can't go on outside of those boundaries. So this is an introduction to basically linear equations. A lot of this stuff in terms of table of values you had to graph in grade 9. I know that you had to do slopes and intercepts, okay? You had to also think about parallel lines and perpendicular lines. So you can go back to that first playlist, okay, that I showed you, okay, if you wanted to refresh yourself. But this I definitely wanted to talk to you about because it might be a little bit new in terms of domains and ranges and then restrictions. So this is great, okay, in terms of an introduction to your kind of grade 10 linear equations. All right, we'll see you in the next video, okay? Take care. Bye, everybody.